Hello, I'm Batmaning, and I'm here to say Manning math is the way to go.
Holy cow! Guest speakers! Where did he come from?
Where did he go? I don't know. He'll be back someday, I'll bet. Anyways, for now, I hope you all caught on to finding the assignments, finding the lessons everywhere. This is tonight's. I will have talked to you about this a little bit today during our conference call, hopefully, today being Tuesday. What we're going to talk about today is systems of nonlinear equations. This is chapter 7.4, which would be your assignment given for tonight. So you're going to work on that tonight after having listened to this, and then you'll be able to ask questions on this the next class day, which would be Thursday, the 26th. Okay, so hope all that's working well for you all. Hope this isn't too big of a deal because you know what? This is something that we've already done before. We've done all the parts here. We're just turning it up a little bit, you know? It's systems of equations, right? But instead of linear equations, you know, we're going to do nonlinear, which means we're going to have things like parabolas, circles, ellipses, all those shapes that comes from cones, conics. So we might do some linear ones with them. So we've got to think about how many answers could we get. So think about this for a second. When we did a system of equations, you know, we get our one answer where two lines crossed. However, in this case, things are going to be a little different. Now what's going on is, let's say we've got a parabola, right? You can see how a line could cross that in two different places, here and here. But you could also see, I'll bet, how a line could cross that in only one spot, where it touches as a tangent. So there'd only be one solution. Or what if it never crossed, right? So we have the possibility in this case of 0, 1, or 2 solutions. How many is the most you think we could get if we talk about parabolas, circles, lines, ellipses, or just like, you know, flattened out circles, ovals? What other things do you think we could get? How many more could we get? What's the most we could get? Well, let's see. Let's take a circle. Well, we could see a line again could do 0, 1, or 2. And we could probably see how a parabola could go through it 2. I mean, it could also do none. But what about a parabola getting to 3? Okay, so we've got that. Okay, so we've got 3. Is there a way we could get to 4? Could we have 4? Well, what if we had a circle? Oh, let's take a parabola. Doesn't matter, parabola or circle. And then what if there was a circle within going through this parabola? That's more of an oval, like an ellipse. But you can see how a circle could do the same thing. So we could get 1, 2, 3, 4 different answers. Could we get 5? Not quite this way. You know, there is a possibility if we get to one of the more complex conics, I would say like a hyperbola or something like that. Hyperbolas within hyperbolas maybe. But for right now, we're going to limit ourselves from 0 to 4. Okay? So, first things first. This being trigonometry class, you all know what I always like to say. Draw it if you can. Draw it, draw it, draw it. So in this case, let's take a look. This here, that's a parabola, isn't it? That's a parabola. If we change that around a little bit, if we move that 4 over, we get x squared minus 4, and then we divide by 2, we'd end up with y equals 1/2 x squared plus 2. Actually, it's going to be minus 2, isn't it? So we have to move it over there. So it's going to be minus 2. So what's that telling us? It's going to open up because the a is positive. It's going to go down 2 units. And it's going to have half the slope. So instead of over 1 up 1, we go over 1 up half. Over 2, we normally go up 4. Over 2, we're going to go up 2. So we're going to have something closer to this. Now all I'm doing is a sketch right now, so I have an idea of how many solutions I should be expecting. Over here we have a line. Let's get that y by itself. Let's write that as y equals mx plus b. So if we were to move the 2x over here, we'd have negative y equals negative 2x plus 2. Divide out the negative. This is going to turn into y equals, so that's negative. This came over as negative, but we divided it out. So that's going to be positive 2x. And that was already negative, but divide out the negative, negative 2. It was already positive, divide out the negative. So what do we got there? We've got a line that goes through at negative 2 right there and has a slope of 2. Something like that. So I'm seeing two solutions. We should have two separate answers here in this problem. Now, how are we going to do this algebraically? Because we know that graphing is not the best way to do this. So what we're going to do is we're going to remember when we did linear equations, we had what two methods? We had substitution and what was the other one? Right, elimination. So substitution, elimination. Now here's the thing. You might also be thinking of the graphing calculator with reduced row echelon form, RREF, or matrices. Those work with linear equations. These aren't linear, so it's not quite going to work for you there. So we've got to do substitution or elimination. Remember, that's why I told us we had to still know that. So what are we going to do here? In this case, let's do substitution, because remember, substitution is easiest when you can get one of the variables by itself. Like that, right there. We've already gotten the y by itself. So we know that y is 2x minus 2. And so what we're going to do is we're going to substitute that into the other equation in place of the y. And then we're going to solve it, because we'll have gotten rid of the x, or the y that way, and we'll have an equation only in x's. So let's see what happens here. Let's say x squared equals 2 times y plus 4. And what did we say y was? Well, there it is, 2x minus 2. So let's solve it. What do we have? We have a quadratic to solve, so we know we need it to equal 0, right? So we could hopefully factor it, which probably going to be able to factor these. If we can't, there might be one or two in here that you can't. Be ready to use the quadratic formula or completing the square. But more than likely, we're going to be able to factor these. High school math class, right? So let's distribute here to start putting this into standard form. So we would have x squared still equals 4x minus 4 plus that 4. Okay, well, gosh, minus 4 plus 4, that's going to cancel. That makes life really nice. And it is a quadratic, so we want it to equal 0. So let's move the 4x that way, because we always like our a, our leading coefficient, to equal a positive, right? To make factoring easier for us. So what we're going to do is we're going to subtract 4x, and we're going to get x squared minus 4x equals what? 0. Now at this point, there's no constant, so we don't have to worry about FOIL factoring. We can go straight to just regular reversing the distributive property. So they've got a common x, factor x out, we're left with x minus 4. Remember, x times x is our x squared, x times minus 4 is our minus 4x, still equals 0. And now we can use the zero product property. So we can set x equal to 0, well, that's an answer. And we can set x minus 4 equal to 0. Here we have to add the 4 to both sides, and we get x equals 4. So notice we have two solutions for the x value. We expected two different solutions for the x value. That's good. It's not 0, 4. That's not the point. It's not x, y. Those are two different x values for our two different solutions. So we're going to note that guy. We're going to note that guy. And we can come over here. We can say, well, we know part of the answer already. We know it's going to be 0, something, and 4, something for those two solutions that we've been given. Now, we can see on the graph where it is because they're nice whole number answers. But if they weren't, we'd have to be doing the algebra. So what do we got going on here? Let's substitute to get our answer. Now remember, one of the reasons we love substitution, way back at the beginning, when we isolated our variable, we've already created the equation that's isolated the variable that we're looking for right now. We're looking for y. There it is right there. So that's what we're going to use to finish this up. So we're going to say, well, y equals 2 times x minus 2. Let's put in the first x, which is 0. So 2 times 0 there is 0. So we get y equals negative 2. Bam. And which one does that go with? Right, that goes with the 0, because that was the 0x that we plugged in. So our first solution is 0, negative 2. We move on. Do the same thing again. Y equals 2 times x minus 2. We're going to use the x value of 4 this time. So we're going to put the 4 in there. And we're going to realize that 2 times 4 is 8. And 8 minus 2, y equals 6. So that y goes with the x of 4 that we just plugged in. Does that look appropriate? 0, negative 2, bing. 4, 6, that's looking pretty darn good. Good solution. Okay, so you got the idea there for substitution. Isolate a variable, substitute that equation back into the other equation, solve. Find your answers, plug them back in to that isolated equation to get your other parts of the answers. Draw the question or draw the equations every time you can. Draw it. Look at it in your graphic calculator, whatever it is. Draw it so you can see how many answers you should expect to find. Okay? Now, with this problem over here, this one's a little bit more complicated. So, getting x or y by itself would be pretty easy. If you got x by itself, you have to plug it in here and here, which means here you'd have to square the binomial. Because getting x by itself, you'd have, what would that be? You'd have the y and the 2 together. So you'd have a binomial to FOIL there and the negative 8 to distribute there. If instead you got the y by itself, you could just plug it in there and distribute the negative. That would be a pretty good way to go. But we're going to use this one as an example of how to do what they call the addition method, or in other words, the elimination method from what we learned in algebra. The addition method, notice they're not saying the addition-subtraction method. They're pushing you in that direction of always get opposites so you can do addition, like I talked to you about in class as well. It's a good idea to do that. You don't have to do that, but it's always less likely to make a mistake that way, which is a really good idea to go forward with. So how do we do that? Remember, elimination method or addition method is easiest when both equations are in standard form. Well, here's in standard form, ax plus by equals c. And this is actually in standard form as well. Remember, ax squared plus bxy plus cy squared, which isn't there, and the xy isn't there, plus dx plus ey equals f. So we're already in standard form, and hey, look at this. If we do addition right now, the y's eliminate. Now, here's the thing about doing the addition method with nonlinear equations. You have to make sure that you get rid of all of the same variable. So that's why we would go with the y here, because if we add it together, there are no longer any y's in that problem. If we went for the x, notice that, sure, we could maybe multiply the bottom by 8 and get rid of the negative 8x and positive 8x, multiply by negative 8, I guess, but that doesn't get rid of the x squared. So you'd still have the x squared in there, which means you did not get rid of the variable entirely. You only got rid of the singular version of it, not the squared version of it. So look at your equation first and decide what's the best way to go. Substitution, is it real easy to get one variable by itself? Or elimination, is it pretty easy to add or subtract to get rid of the same variable? In this case, we're going to do elimination, so let's give it a try. Now, we noted that if we do addition right now, negative y plus y cancels or eliminates. And that's the point of this whole system, this whole technique. So now x squared plus no x squared would be x squared. Negative 8x plus negative x would be negative 9x. That's eliminated, equals negative 16 plus negative 2 would be negative 18. Now again, it'd be nice to graph it. We're going to do that afterwards to see if our answer looks appropriate. So we've got this. Notice we no longer have the y variable in there. We've only got x's. Now we do have a quadratic to solve. Why? I expect we have more than one solution. Remember, There is a parabola, and there's a line. So we possibly have something like that going on again. It might only touch it in one place, or it might not at all. We're going to see. So we continue forward. This is a quadratic. So we're going to have to move that plus 18, aren't we? Let's go ahead and change color a little bit here. Let's go to green. Get rid of the purple. So let's add 18 to both sides. And when we do that, we still have our x squared. We still have minus 9x, because that's not a like term with the plus 18. And now over here it equals 0. So now we could look at this to try to factor this quadratic. Now again, like I said, most of these are going to be factorable, so give it a try. I'd give myself a minute. I give myself about 30 seconds. I give yourselves about a minute. If you can't factor it in a minute, go on to the quadratic formula. Now 18 could be 1 and 18, which won't get me to the 9. It could be, what's that, 2 and 9. That's not going to get me to a 9. But it could also be 3 and 6. Aha! 3 and 6 multiplies to give me 18, but it also adds up to give me 9. But it has to add up to be negative 9. So let's give it a negative and a negative, which still multiplies to be positive 18, but now it's going to add up to be negative. So as you guys can tell, I know you've done this many times before, you can see right now that we know x equals 3 from the zero product property, and x equals 6 from the zero product property. Solving each of these for 0, and then moving the 3 and the 6 over. So we've got two answers for x again. Remember, they're not together as an ordered pair. These are two beginnings of ordered pairs. So we know our answer is going to be 3 comma something and 6 comma something. Now, what are the other values? Well, now in elimination, remember, we didn't isolate a variable like we did over here in substitution. So we're going to have to decide which one looks easiest to work with. Yeah, I'm with you. The second one here for sure. And since we know what x is, we're just going to solve for y. And look at this. We could really quickly move x over and write our equation as y equals x minus 2. See, notice what I did. I added the x over here, so I have x minus 2 now equals the y. So let's go ahead and plug in the 3 for the first one. And we can see now that, what's that, 3 minus 2, y equals 1. That goes with that guy. Bam. And then let's do it one more time with the 6. Y equals x minus 2. And again, you can see when we put the 6 in, we get 6 minus 2, y equals 4. And that goes with the 6. So those are our two solutions. Let's graph it and see if that looks appropriate or not. So in our top equation, here, we've got that. Gosh, let's get y by itself and recognize that this could be the same as y equals, so think of moving y over here, and now move the 16 over there, x squared minus 8x plus 16. You know what? That factors. That's a perfect square trinomial, if you didn't notice, as x minus 4 squared. So for graphing that, we can very quickly see h is positive 4, 1, 2, 3, 4. K is 0, so it's not up or down any, and a is 1. So it's our parent shape, basically like that. Now over here, like we did before, right there, y equals x minus 2. That's our linear equation. Y equals x minus 2. That's a y-intercept of negative 2 and a slope of 1. So it goes like that. So now, total estimate here, right? Because I just scratched this together. Does that look like that could be 3, 1? And does that look like that could be 6, 4? That looks very appropriate. So I think that's really good, folks. That's the basic idea of systems of nonlinear equations. I will answer more questions, and I'm going to do a second video in a moment so that I've got 2 more examples. I want to do one more example that's a little bit more complicated than this one, and I want to do an application example too to go along with why would we want to know how to do this and how do we do some of those word problems. So at the end of that one, I'll tell you the homework again. If not, you can always find that in Teams. And I've actually started putting the daily objectives and the homework in the description for the Adventurous YouTube channel. So feel free to look there for that as well. And feel free to do the daily objectives with your notes also. Until then, I'll give you the joke next video. See you then. Bye.